So it's 2 o'clock. This is another of our CERN container webinars. Welcome everyone. So today's topic is managing Kubernetes deployments with Helm and Flux, and some examples of how we are doing this at CERN. I'll give this talk today. There will be, you can find the link of the agenda there. You can also find in the same agenda the other webinars that we have planned coming next. So it's quickly about me. I'm a computer engineer at CERN, in the CERN cloud team. I focus mostly on containers, Kubernetes, and the networking aspects. And then I'm also very interested in accelerators, GPUs, and similar accelerators, and also machine learning. Previously at CERN, I had different tasks, but I worked in storage systems, monitoring, and also components of the worldwide LHC computing grid, which is the infrastructure we use to process the data from our experiments. You can reach me using these 2 contacts. If you have questions or anything you need, feel free to contact me directly. For today's talk, also, I'll give a brief overview of each part, and then we'll jump into hands-on demos. But feel free to raise your hand or leave a question in the Q&A box, and we'll handle it during the talk, or if you prefer, also at the end. I'll try to stop also in between sections if there's something to raise there. So quick outline. This is the first webinar we record in this using this tool. So I'll start by covering basic Helm usage. I'll go quickly here. There's plenty of documentation online. Then we'll jump to GitOps, which is the main thing we want to cover here, and how we rely on Flux to achieve this. And then one of the main aspects of all this whole workflow is how to handle sensitive configuration data and secrets. So I'll describe a tool called SOPS. If you've tried similar setups that we recommended at CERN, we used to have this Helm plugin for OpenStack Barbican. But actually, there was some manual steps to be done in that setup. So using SOPS is actually an improvement, as Flux has native support for SOPS. And then at the end, I'll describe some use cases for multi-cluster deployments. So let's start with the principles behind all of this. If you are using Kubernetes, you know that one of the big advantages is that you're doing a declarative definition for both your infrastructure and all your applications. So in the manifest, you define all the resources that are part of your application, and you define all the characteristics of all those resources. And this can be the image that they are using for the application. It can be the resources, CPU memory that they should use, things like liveness probes, readiness probes, number of replicas. And then the orchestrator, Kubernetes, will try to apply those and make sure that whatever you defined is always kept within the definitions you gave. So once we have this, the goal here is to take those definitions and put it in a single place that will become the single source of truth of how the deployment should look like. And we rely on Git for this, thus GitOps. And the advantages there is that if you use a version control system like Git, basically every time you do a change, you get proper versioning. You can do branch and pull requests and get people to review those changes. You can integrate it with your continuous integration for validation. If you see a problem, you can also easily roll back. You also gain a bit in terms of authentication and authorization as moving it to Git. If you already have this layer there, you can just define who is able to change the configurations directly in Git, and you don't have to share the credentials to access the cluster with a larger amount of people. You just need the people that need to debug this directly in the clusters, or any problem directly in the clusters, to get those credentials. And then the last step is that all of this should be automated. Otherwise, there's little point in doing it. And this is where Flux enters the game. So I'll start by covering Helm. Helm is a graduated project hosted in the Cloud Native Computing Foundation, the CNCF. It's quite popular. It's described usually as the Kubernetes package manager, in the sense that it wraps whatever manifest you have to deploy your application in a single unit, which is called a chart. And this is your deployment unit. You can also reuse the same deployment unit for multiple instances of your application with slightly different configurations. You can share these charts by publishing them in repositories as well, so that they are easily discoverable. And then once you have these templates defined for your Kubernetes deployments and resources, you can have the configuration defined in values, which allows you to do slight tweaks depending on the instance of your application. Helm is not the only tool that exists for this. It is very popular. Another popular option is Customize, which is a slightly different focus, not so much on the chart and sharing, but on the overlaying of changes. The benefit of Customize is actually that it's integrated into the kubectl command these days. But still, in this case, in this demo, we'll use Helm because it matches very well this way we do things, where we very often have multiple instances of the same deployment, but we also want to build on upstream charts for common components. So we'll jump straight to the demo. So in this first one, we'll cover basically the Helm part. So I have a cluster running with Kubernetes, and here I'm doing Helm ls -a, which shows all the Helm deployments, and we see nothing. And then on the top, I'm monitoring the pods and the persistent volume claims created in the cluster, which is also showing nothing because we haven't deployed anything yet. But let's start by, I mentioned Helm has repositories as a way to find charts. Let's start by what I have here. So in this case, I have 3 repositories defined. One is Flux, because we'll need it for later. The other one is CERN, and this is an internal Helm chart repository that we use for internal components. And then Stable, which used to be, or is still the place where all the charts were being put. This repository is actually being deprecated, and in favor of splitting the charts in multiple repositories instead of having everything in the same Git repo. This will make things much more easy to evolve in the future. So if we want to search for a specific component, let's say we want to search for MySQL. I need to install MySQL. I do Helm search MySQL, and I can see that the first one is this MySQL repo from the Stable repository that we'll use today. And then there's some related components as well. As I mentioned, this Stable repository is being deprecated in favor of what's called as the Helm Hub, where multiple repositories can publish their charts. So if I do the same, you can see that here I have the URL of the repository and the chart where it is, and then similar information regarding the chart and app version. So the equivalent of this MySQL one would be the one hosted in the Bitnami repository. For today, we'll rely on the Stable one. And then because we are at CERN, you can see what we are providing at CERN, like the kind of thing we need to define internally. So things like Prometheus specific configurations for CERN, so that everyone is pushing the same kind of metrics. We have a Condor batch system. So this is the setup for start-d. CVMFS is an internal file system. EOS is the large storage system that we have for physics data, things like this. Okay, so that's for repositories. Now to install with Helm, it's as easy as this. You'd say upgrade and I put -i, which means if it's not there, install it anyway. And then I name it with MySQL and I say which chart should be used. If I do this, it says that the chart is still not there, so it will install it. And we can see that immediately in the cluster, we see a Helm component being released and something starts showing up in our namespace here. One really good thing about Helm also is that it has this way of giving some feedback to the user when the user deploys the first time the chart, and it tells you things like how to get the root password, how to access the container, things like this. So this is, if you're developing charts, this is very interesting, and you should provide these notes files. So if I go, actually, it should be in the directory. if I go here, so I cloned the upstream repository, and this is the chart. So I'll just show you what is in the chart. So basically a chart is defined in this chart.yaml, all the metadata like the name, the version of the application it's deploying, and then any additional metadata that you might require. And then you have the templates, which are basically the Kubernetes manifests of the application you're deploying. So things like deployment, service accounts, the persistent volume claim we see above, the service, etc. The main difference is that instead of having the normal deployment, you're actually having a template. So here we see a Kubernetes deployment, but it's all using Golang templates to fill up on some parts of the manifest. This allows us to have it configurable so that if you want to have multiple instances, you can override some of these values. You can see here .values. This is where the some configuration of this deployment will be, and then the templating system will just fill them up appropriately. And it's really useful for things like if you want to override the image that is being used. For example, here we have values image and the tag, the resources that should be assigned for a deployment, things like this. But it's pretty flexible. You can do conditional like ifs, and you can also do loops. So basically, that's what is in the chart, and then the configuration. It's stored in these values. Usually, every chart will provide these values.yaml, which is the default values. So this is what, if I don't provide any specifics, then these are the defaults that will be taken. You can see the image and the image tag that I mentioned. You can also see something like persistency. And here it's saying that persistent is enabled, which means it's trying to create a persistent volume claim that would be used to store the data in the MySQL database. And that's the reason why in our example here, you can see that our pod is still pending. And the reason is that it's trying to get a persistent volume, but the default configuration, it's using a default storage class that we don't define. So it's enabled to define this persistent volume, so the deployment is stuck. So then one thing that you will always do basically is that you will need to override some of the default configurations. So you can do this directly by setting the values directly here. So we saw in this values file that there was persistent and enabled true. I'm setting persistent enabled false, and we say the same command, just overriding one value. So this will try to upgrade the deployment of MySQL in our cluster. You can see that it already said here revision 2, and it deleted the persistent volume claim because we don't need it anymore. And immediately the pod is now in running state. So there's some initialization being done, but it's already there and running. Again, on every upgrade, you can see some valuable information here, like the revision, but also the instructions on how to access your database. So this is nice, but if you think about it, if you have like 100 parameters to override using this one scale, so it's much more common to use a values file of your own. So if we go here, yeah, so here I have a values file that looks a lot like the default one that I showed before, but I just override whatever I need, and these are given priority compared to the other ones. So here, in addition to the persistency, I'm going to override the resources, and I'm putting CPU 300 mil. And if we check quickly the current value, so that we see that there will be an upgrade. So the current value for the resources is here. So it's 100 mil. So in my custom values, I'm setting 300. So what we will do is, again, the exact same command, Helm upgrade my instance, MySQL, and then instead of passing a specific value, I'm just passing the file that has my configuration, my custom values, and then the chart name again. So we should see here revision 3 soon. There you go, revision 3, and you can see that it's terminating the pod because we changed the resources that the pod requires. So Kubernetes needs to create a new pod basically to comply with this, and it's pending and should be there. Okay, back to running. And now if I describe, oops, sorry. So if I describe, if I get the definition of this pod now, we should see the resources updated here somewhere. Oop, too far here. So CPU 300 mil. So it updated it. So that's quite nice. It's very fast, as you can see, thanks to Kubernetes, of course. But so another thing that is quite interesting, we saw here that we have 3 revisions of this deployment. So Helm keeps track of all this history. So if I do Helm history, MySQL, I can see that at some point I have the first install, then I did a first update that was to set the persistency, and then a second update to set the resources. This is really nice, but say, for example, I did this change, but I want to roll it back. So you can do this very easily as well. Just Helm roll back MySQL, and we want to go back to revision 2 that had the initial resources. So rollback is a success, and we see revision 4. So Helm always moves forward. You can see that it created again the pod. It's back to running. And if I see history, I see that revision 4 is deployed, and actually it was just a rollback to revision 2. And that's pretty much it for Helm for a quick introduction. So it's quite easy to use. I'll just delete this here, and we can move forward to the next topic. So deletion is also like quite easy. You can see that it's gone now and just terminating, and we are back to square one. So I don't know if you have questions, feel free to raise your hand and we can answer, or I just move forward. So the second part is GitOps. So this was all pretty manual. You can see that I have my values file. I do all these commands manually. So this is kind of time consuming, and it's not very automated. So the principle of GitOps is to have a single source of truth for this declarative infrastructure applications. I took this from the Weaveworks website. Weaveworks is a company that is pushing a lot for this kind of model. One main part of GitOps is that for most applications, you won't be deploying a single MySQL database like I did here. You will probably have a much more complex application that will have a web front end, a MySQL database, maybe some additional tools to do some statistics. So it will be made of multiple components. Each component will have its own Helm chart, but you need some kind of unit to aggregate all of this. So this is the concept of an umbrella or meta chart. This is the way to define a Helm chart that doesn't necessarily have its own manifests. It only has a bunch of dependencies, and it allows you to have a single unit of deployment and provide all the configuration for each of the components in a single place. And then, of course, what we want to do is automate all of this. So here in the diagram, you can see that you have your Git repository where all the configuration is located. You push some changes or the initial change, and then in the cluster itself, you have all these components running. Basically, 2 main ones. It's Flux, the Flux component, and Flux. What it does is it's listening. It's monitoring the Git repo for any changes based on the commit ID. When it sees a change, it enforces those changes into the cluster. So in our case, we want to use Helm. So we rely on what's called Helm releases, which is a Kubernetes custom resource that defines which Helm chart should be installed. And it will be this meta chart that has all the dependencies. So these Helm releases are Kubernetes CRDs, and we'll see in the demo. And then the Helm operator is a component running in the system as well, which also comes from the Flux tooling. And it's listening to changes and to new custom resources of type Helm release. And whenever it sees, basically just does Helm upgrades on the cluster. So basically what I did manually, it's doing in an automated fashion. So this should allow us to not even have to interact with the cluster, just interact with the Git repository, do small changes, and everything should propagate. And if you think about it, I can deploy this setup in one cluster, and it will monitor the Git repo. I can deploy a new cluster, deploy Flux pointing to the same Git repo, and that suddenly I have the same application running in 2 different clusters. And you can decide to have the same setup, or you can decide to have slightly different setups. So this also makes multi-cluster deployments much easier. So for the demo, we'll do the left example, but I want to give you some use cases where this kind of thing can be useful. So the first one is on the left is kind of having a rollout staging release, where you push changes, but you want to expose them first in a staging environment. And then when you're confident, you have your production environment. So this is very easy to do with Flux, and we'll see in the demo. And then on your load balancer, you can just redirect like 90% of the top traffic to production and expose the new features to 10% of the users. This is kind of traditional rollout. And then on the right side, because there are many other use cases for this kind of thing, you could think that to do some kind of A/B testing where you have your main control deployment with the current metrics, and then you deploy some variant of your tools, and then you want to kind of evaluate a specific metric to see if that variant has an improvement or not compared to the control deployment. And you'll probably in the load balancer, you will randomize the access so that this is kind of statistically significant, and then you can evaluate this metric. So actually, this is very easy to do with this load balancer, but Flux also has some built-in support to automate even the monitoring of the metrics for you. So in the demo, I'll use this repository here linked. This is some GitOps example that we developed a while ago. So I'll be using that one. Check that I'm in the right place. Okay, so here, in this case, we'll be watching what happens in our production environment. So I'll watch the namespace prod, and we'll watch both services and pods. And GitOps getting started. So I'm in the right place. I'm in the right branch, hopefully. Okay. So the first thing that I want to show you is this umbrella chart. So this is the Helm, the Git repository that you would see in this link. The definitions inside follow a structure that we decided internally, and this is quite common for Flux, but you don't have to do it. But the goal is to have a charts directory where we define our umbrella chart. That's called GitOps Getting Started. As you see, it has no manifest. It only has a charts YAML file. And if I go here, it's the same kind of metadata. It's actually using Helm v3 in this case. So you can see like the name and then all the dependencies that we have. So in this case, we'll use a WordPress application. And then you have the default values that configure all your instances. So in this case, we have the configuration for our WordPress sample application. We are saying persistence false, and we say that the service should be exposed in a load balancer. But also think about it, the WordPress chart is actually bringing its own dependencies, but that they will just come automatically. But still, you can provide the default values for those dependencies as well. So here is MariaDB as an example, and we are just specifying some user here, and also that we are disabling persistency. So this is the default that all the deployments should have. And then in the releases, you can have the overrides for each specific instance of the application that you want to run. So first we have a production one from our example. And if we look at it, we are defining it as a Helm release. So this is the custom resource that we saw earlier. We say that it should be running in the prod namespace. We give it a release name, which is basically the Helm release name. And then we say in which repository it's hosted and which branch we want to use. So usually you would use master for this. In this example, I'm using plain secrets because I'll need another branch for the SOPS demo. But you could say, for example, the production one uses master. You could also say that the staging one is using master because you have the separation already in this Helm release. Or you could say that the staging one uses a staging branch if you want to handle it using branches. But the main thing is that we are providing some additional information for our production in addition to the default values. And the main one is this blog name, so that we can, in the demo, differentiate the production from the staging. So we're calling it blog production. And then we are specifying passwords for both the DB and the root user. So these passwords in this case are still plain text, but we'll do the demo with SOPS after. And then in our staging environment, it looks very, very similar, just the namespace is different. I'm using the same branch in this case, but then I override the blog name with something else. So basically you could override whatever parameters you have defined in the main chart. You can just override them here, which is a very simple way to have these environments. So if we go here, sorry. So if we go get Helm release -- all namespaces, we shouldn't have any release yet because we don't have anything running. So what we will do is we'll install first our Flux tool. So to install Flux, I have to set the proper branch here. Also Flux, what we are doing here is specifying the Git repo that Flux should be looking for its changes. Optionally, you can define a branch. In this case, for the demo, I am doing it. So let's just deploy it. And once it's deployed, it should show up in our cluster here. So we have it. Again, it gives you some nice information on how to interact with it, but also it gives you can parameterize how Flux is running. So the main thing you're interested in is this poll interval to Git. So here I'm saying that it should try to look for new updates in the Git repo every minute, which is quite aggressive, but actually if you think about it, it's only once per deployment in the cluster. It's not like per VM, per node or anything like this. So it's not that much load on the Git repo. And then you can also define like if Prometheus monitoring should be used or not, how much resources we are giving it to it and things like this. So if I do Helm release again, I actually already see that it created 2 Helm releases, one for prod and one for staging, but they are not created yet because nothing is they are not deployed yet because the Helm operator is still not there. But if we look at the logs, it's quite interesting here. So it just started here. And then you can see that at some point it synced with the upstream repo and it used, this is the commit ID that it found. It found a new commit ID, so there was something to do. And basically it applied this this command that basically does kubectl apply of the Helm releases. So to actually get our deployments done, we need to deploy as well the Helm operator. So the Helm operator is this command here I'm doing. Again, we're just deploying a different component and this Helm operator value. So I'll just deploy it and then we can have a look at what the values show. So we can see that yeah, the deployment is there. Again, nodes are super useful. If you define your charts, definitely do them. And then in the Helm operator, we see similar configuration parameters. And this is things like the sync of the charts with the upstream repos to look for like new versions in case you're not specifying a version for the dependency. Also the poll interval for the Git repo. Again, I'm doing it in 1 minute. Here I'm specifying that I only care about Helm v3. There's also support for Helm v2, but definitely if you're doing a new deployment, you should be relying on this v3. It's a much easier life. And then the Prometheus monitoring, as Flux does, also the Helm operator has the ability to expose some metrics, and then the resources. So if we check the logs again of the Helm operator, so here we saw that it started, and then suddenly it started looking for new Helm releases, and it found some. It found our prod and it found our staging. So it synced with the repos that required all the charts for the dependencies. And then finally it started deploying the installation here. So running installation, and we can see what it's doing after. And we can see now that without doing anything, just deploying Flux and the Helm operator, we have 2 new Helm applications running, one for our staging application and one for our prod application. And if I do get Helm releases again, I can see that now not only it's telling me that it's deployed, but also gives me some additional information that is quite useful. So, and in our prod environment, I now already see my database is running and my WordPress is at some point going to be also ready. So it's still deploying. But we can see like the WordPress application getting ready to be served. Now, if you remember, I also defined the service that it's being exposed as type load balancer so that I can access it from the outside. So this is the IP. So at CERN, we have this integration with the OpenStack load balancer as a service, which allows us to just define, and this is created in our OpenStack environment. Same that you would get in like GCP or Azure or AWS. So if we try to access this IP, we see our block production. So it's already exposed here. And it's like exposed like this. So if I do the same, but I look for the staging environment, we have, again, a very similar deployment, but we see that the IP is different for the load balancer. So if I go here, I see the staging. Now, this is not so useful. Like we have two different endpoints for the staging and for the production. So this is not super useful. Now, one possibility to handle this is if I do load balancer list in my OpenStack environment, I can see that I created earlier another load balancer that currently has no members. But that I can use as the top level load balancer. If we go back to the picture here, I have a top level load balancer, and then I have the two from each of the production and staging environments. So what we can try to do is just add, let's see, we can try to add it here. I can probably watch it. List. Yeah. So here it's saying, so into members on the top, we have no members, but now if I create the members. Yep. So for staging, we had, let's see, 29. So I'm adding the staging environment to the pool. And then so we already have the member on the top. And then for the production one is 26. So 26 is a new member of our load balancer. And I just do production. And we should have a new member here soon. Okay, so basically now we have this this top level load balancer that has, if I do load balancer list, that has its own IP. So I just want to fetch it here. I probably already have it here. Yeah. So before it was showing nothing because I had no members, but now it's showing production. And then if I refresh, it flips to staging, back to production, flips to staging. So this is already doing the job, but what we want as well is to set the weight. So I want the production endpoint to have more traffic than the staging one. So I just change the weight directly in the load balancer. And this takes a couple of seconds to be applied, but at some point, yeah. So now I start seeing a lot more traffic in the production one. And then from time to time, yeah, it takes a couple of seconds. Yeah, from time to time I get to stay. It takes a while to stabilize, but you see the point here now. Yeah. So this is basically a very easy way to have most of the setup managed by GitOps, and then having this kind of different environments. So now this is all nice. Now what we really want now is to see how it works if we do a change. So if we go and edit our production environment, I'll just change the here to change the name of the endpoint to live webinar. I do the change. I push this to my repo. And then if we look at the logs of Flux, we should see that at some point it should recognize the, what should be the prod? It should recognize the change in the next cycle. So that, again, this can take like up to a minute. I put it for 1 minute to be pretty fast, but yeah, sometimes they're just unlucky. So here it says it's synced, it detected a change and it's syncing against this commit ID. So basically, if I do a git log, we should see, so 31871, 31871 is the commit ID that I just pushed. So if we do get Helm release, we can see if I go to the prod environment. Oops. We should see that Flux already applied a change in the local cluster. So the Helm release already has this live webinar string on it. Now, the next step is that in the next cycle of the Helm operator, it should detect that there was a change in the local Helm release, which means it needs to do an upgrade of the release in the cluster itself. So again, this can take a minute or so, hopefully not too long. Yeah. So here it already, yeah. So we can see that it detected a change and now it's applying the update for, so in the staging one, it didn't see any update, but in the production one, it required to do a Helm upgrade, and you can see that our revision is now 2 here. And you can see that it had to create a new WordPress container because I changed some of the configuration. So it's being deployed. Once it's ready, it will just terminate the old one and it will just flip to the new container, and we should start seeing, there we go. So it's terminating now, the old one, and we should already see traffic with the new string here. So we did an upgrade and it's pretty easy. So all I had to do is do a git push and then all the rest is fully automated. And that's it for this demo as well. So I'll just do a clean of all of this. So basically, this is an example with prod staging, but you can imagine like multi-region, different flavors of releases. This is all pretty easy to do in a similar way. So then the last step for today's webinar is this handling of sensitive data. I mentioned that we used to have a plugin for Helm, but actually we started now relying on SOPS. So SOPS is an editor for encrypted files. It's developed by Mozilla. It supports and knows about how to handle YAML, JSON, INI binary files. And mainly what it needs is a place to handle master keys that will help generate the data keys that do the encryption. And it supports by default a lot of key management services like AWS KMS, GCP KMS, Azure Key Vault, and also PGP. The HashiCorp Vault support is under review, and the OpenStack Barbican, I wrote it and added just very recently, so you can go to the pull request if you want to know more about it. The main reason, again, is that SOPS is supported natively by Flux, which makes our life much easier. As long as we rely on this, Flux will just be able to handle the secrets. The way it works is that there's 2 parts in the final encrypted message. The first one is to do the encryption of the plain text. So for that, what SOPS does, it generates a data key, and it uses that data key to encrypt the plain text and generate the ciphertext. This is part of it. And then takes that data key and encrypts that data key itself using a master key. And this master key has to be very safe and stored securely. And then the encrypted data key also goes to the encrypted payload. And this encrypted payload is safe to store in like a public repository as long as the master key stays safe. You can even have multiple master keys. You can add and remove master keys to an existing file and then remove all the master keys if you want to do rotation, for example. So it's quite nice. So let's jump straight to the demo. So this will be very similar to what we've been doing earlier. But I'll show you the steps for SOPS first. So the first thing with Barbican is actually we'll generate a master key, and the master key will have the key itself and then some nonce for the initialization vector. If you use, for example, GCP or AWS or any other KMS, you actually don't have to do this. It's supported natively. But in our case, what we did is we generate this key and then we store it using our OpenStack credentials in the OpenStack secret service. The main thing here is that the project holding this master key has to be the same as the project where the cluster is, your Kubernetes cluster is deployed, so that the cluster itself can retrieve that key. So it generates this key ID, and this is what we will use to encrypt our secrets in this repository. So actually, I need to check out this, yeah, just to be in the proper branch. So basically, yeah, so my recommendation is that you generate a master key per repository and then use that as the master key that you will use for all the data inside that repository. There's a very handy way, which is to create this .sops.yaml file where you put the reference to the master key. This is safe to share. And then you can also specify a regex that says which keys should be encrypted. By default, it would encrypt all the keys. That makes it not very readable. So if you only have to encrypt passwords or anything ending with key, then you can use this regex. So that's quite useful. And yeah, so I would suggest that you create this SOPS file. You can also pass it manually, of course, but this is quite handy. And if you see the help file here, you can see that it has options for decrypting and encrypting, and then you see all the backends that it supports, so GCP, KMS, Azure, HashiCorp Vault, PGP, and in our case, we also have added Barbican. And it's being reviewed for usage. So in this case, I still have my unencrypted data here. So now we want to encrypt this. And what we will do is we'll create the file from scratch, but we'll use instead, so I'll do it here. We'll use instead the SOPS command to do that. And I'm not having to pass a key because I use this SOPS YAML, otherwise you will have to pass the key here. So by default, it creates this sample text, but we'll just remove it. Basically, we just paste the exact same content. We don't have to do anything special, and it knows that it should encrypt anything that is named password. So that's it. It already did its job. So if we look at this file, we now see that the password is encrypted. It has all the metadata that it needs to decrypt it, also the root password. And then you can see all the SOPS metadata here. In this case, we are using a Barbican key. So it has the ref that we passed to it, where the master key is available. So it's kind of self-contained. What this means is that once you encrypt it, even if you wouldn't have a SOPS YAML, if you try to decrypt it, it knows all the information it needs to decrypt it. So in this case, I can see the decrypted data pretty easily. So that's pretty much it for SOPS. Once you have this, what I will do is I'll commit this, and I'll see I encrypted the secrets in the prod environment. So I'll again start the monitoring here. And then once we have this, all we have to do is do exactly like we did before, deploy the Flux tool. I'll just have to change the branch because in this demo, I'm using a different branch now. And the second part is deploying the Helm operator. Okay, and if Flux did its job, we should already see the releases here. And if we do prod Helm release YAML, you can see that Helm was capable of decrypting it. So in the Git repo, we had it encrypted, but in the cluster, we now have the decrypted values. So what that means is that the Helm operator, when it tries to load it, it will already see the decrypted values because Flux was handling it for the Helm operator, and it should just show up here very quickly. I'll just wait a couple of seconds. I can show you something while we wait, so that to show you that something will appear here. While we wait for the deployment, I mentioned that we can actually generate, imagine you want to rotate the master key. So let's say I want to do this. I create a new master key using these two commands. And now on the same SOPS, there we go. So it's already deploying our application. So that's pretty much it. But one good thing that I was mentioning is that you can do something like add a new key. Actually, I have to do -r -i. Add a new key to an existing file. So this is our values file. So now, if I look at the file, you can see that the data is encrypted with the two master keys, and any of these keys is able to decrypt it. So that's quite. So this encrypted actually the data keys that encrypt the data, but we have these two master keys. So we could now just delete the old master key, and we would have rotated the file without having to have any kind of impact on the tools that are relying on these files. Another interesting thing is that you can actually have even different master key types. So you could have like Barbican as your main one, but then have like a PGP based key as a safeguard where you put it in a USB stick in a safe somewhere, so that if things go really wrong, you always have a key that can decrypt the data. And I think that's it also for this demo. So the last topic I'll mention here, because I wanted to do a demo of this as well, but then I realized this will go over time. So I'll just mention this, but I think it's pretty easy to see how by using Flux, it's quite easy to have the same deployment, the exact same deployment in multiple clusters, or even slightly different deployments in multiple clusters. So I'll describe some of the use cases we have for this kind of thing. The first one is actually not multi-Kubernetes cluster, but imagine you have your old deployment based on pure VMs managed by whatever, Puppet, Ansible, Chef. And you want to migrate the application to Kubernetes, but you want to do this gradually. So you can imagine that you would have your Kubernetes cluster configured using Flux, and then on your top level load balancer, you still direct 90% of your traffic to the VM-based deployments, and then 10% to the Kubernetes cluster as you gain confidence. So this is like a standard pattern that we're following when we migrate to services. Eventually, you change this rate where you divert only 10% to the VMs, 90% to the Kubernetes cluster, to the point then at some point you just drop completely VMs, and hopefully you will need less resources than you had before as well. The second use case is to reduce blast radius. So one thing we've seen is that like things can go wrong with the cluster, whatever. etcd is a good candidate, but other things can blow up. Even if you have multi-master, one possibility, if you really want to be sure and reduce the blast radius, you can have, instead of having a single cluster, you can have the same Git repo definition being deployed in two different clusters with the same version, the exact same clusters layout. But instead of having like a single 10 node, have two 5-node clusters, and then split the traffic 50-50. This will allow you to kind of survive if some catastrophe happens in one of the clusters for whatever reason. This is also a good one. And the last use case I'll mention is the cluster upgrades. So this is a very similar picture to the previous one, but in this case, one of the clusters is running 117, and this was our initial cluster. Now we want to upgrade to 118. Of course, you can do in-place upgrades, but another option, if you're not trusting your upgrade procedure completely yet, you can just deploy a new cluster with just a couple of nodes with 118, point Flux to the same repo that you're using for 117. It will deploy the application, start with 10% of the traffic there, and then gradually shift so that you end up with 90% of the traffic there. And then when you're happy, you just get rid of the 117 cluster. And this will allow you to kind of have a, like, I don't know, probably safer transition to a new cluster. It can also be, I'm using as an example a Kubernetes version, but it could be anything. It could be like any change, any big change to the cluster setup. And I'll try to do a follow-up webinar that will cover more this multi-cluster deployments. So just to finalize, one thing I didn't demo here as well due to time constraints is monitoring. So both Flux and the Helm operator show a lot of metrics for monitoring. The Helm operator ones are particularly useful because they will allow you to integrate in your operation dashboards things like how many installs and upgrades are being done, how long they are taking, if they were successful or not, things like this. This is quite really, really nice. The other thing that is, so Flux also has a set of metrics. They're not so useful because it's more operational for Flux itself. And then there's other topics that Flux handles that we didn't cover today. So one is automatically updating the Docker images. So we usually hard code the tag that we want to use in the Helm definition. There is a possibility of making this more flexible so that, for example, patches are monitored by Flux itself. So if you would have a patch version upgrade only, Flux would just automatically upgrade the Docker image. There's a very interesting setup also using Istio for canary releases that Flux handles transparently. So this would also be an interesting topic for a future webinar. In this case, we are not using service mesh. We were just relying on the load balancers. And then improvements on the setup. It would be nice to have multiple repositories per Flux instance. Right now, if you want to have in the same cluster two completely different repositories pointing to different repos, you need to have two Flux instances. It would also be nice to define the weights that I did manually directly in the service type load balancer. This is something we are working on. And then because SOPS also has support for HashiCorp Vault, once we have a Vault setup working at CERN, we can also consider supporting directly Vault instead of going through Barbican. We would need some kind of credentials being propagated to the clusters for this. And that's all for today. So I open up for questions. Feel free to ask about any of these topics. Can you hear me, Spears?
Yes, I can hear you.
Cool.
You raised that yet.
Okay. Maybe it was all clear.
So I can ask one because I was thinking about it during the presentation. While we have two clusters and we want with Flux to have the same configuration in both, is it better to use a different file for each cluster or use some labeling in the clusters?
Actually, the way I've been doing it, where is it? Yeah, here. So the left setup with prod and staging, I basically replicate the exact setup with prod and staging in both clusters. Okay. This is one possibility. So you still have your Flux releases for production and staging, but you replicate completely in all the clusters this split. The other possibility that is also doable is to have a production cluster and a staging cluster. And in this case, you want to have only one release per cluster. So your production release would run in the production cluster, and your staging release would run on the staging cluster. This would allow you also to like gradually test new Kubernetes versions, for example, in the staging cluster. This is also a possibility. In Flux, there is an option when you pass, when you configure the Flux values, which is to specify a list of releases that should be deployed. So I don't have it here, an example, but let me see, because I think in the old GitOps getting started tutorial, we had this. Let's see, go to the old one. So there is an option in Flux, yeah, here. So you can set allow namespace, and this will basically go to the same repository that it's in the Helm operator. It will go to the same Git repository, but it only will manage the staging namespace. So basically allow us to have that, and you would specify one for the production cluster and the other for the staging cluster.
We have a question from Diogo. I will give him speech.
Yep. Hello, Diogo.
I didn't ask anything, sorry.
No, it said Diego.
Okay. Diego, sorry. Can you hear me, Diego? Or maybe he's typing?
I cannot give him a voice.
Okay, just read maybe, or
he just raised his hands. There, Diego, if you can write your question. He wrote it. Okay, so
okay.
Before installing the Helm operator, the Helm charts were installed already. Staging and production, weren't they? Maybe I'm confused. I understood that the Helm actions would only take place when the operator is deployed.
Yeah, so that's the case. So we can actually try again quickly to show you that that's the case. I'll clean up and redeploy everything. But that's exactly the case. So basically the flow is that first you need Flux to sync the repo and create the Helm releases in the cluster. The second component is the Helm operator that looks for this Helm release CRDs. So let's say, let's go here, let's monitor here. So nothing in the cluster. Now I deploy first. It doesn't matter if you deploy first the Flux or the Helm operator, it's pretty similar. So now I deploy the Helm operator as well. So in this case, we now have only Flux and the Helm operator now. We already have, so if I see get Helm releases all namespaces, you can see that the Helm releases are already there. The Helm operator started looking at the Helm releases there. Okay, so maybe I could even have deleted them explicitly because there were a couple of them left there, but that shouldn't. No, actually, it deletes the cleanup deleted them. So there's an error here, but you can see that the age is 9 seconds. So they are just created by Flux. And then if I refresh again, they're still there because in the Helm operator is already running. Oops, sorry. But it didn't pick them up. It already saw them. It's now syncing the charts. So you can see that the Helm operator is already there. And it should be just about to install them. So you can see here that it says phase install for the staging GitOps getting started. So they only show up now. So first you get Helm and Helm operator and Flux, and only then the Helm operator is deploying the actual instances. I think that was the question.
Diego, you write a follow-up if you want, and I will read out another question. It says, hi, first of all, many thanks for this presentation. It's very interesting. I would like to know what's the strong reason behind, if any, about to use Flux instead of Argo CD for GitOps.
Yeah, so actually that's a very good question. There's at least one user I'm aware of at CERN that is relying on Argo CD. It's it's a choice. I would say like when we started using Flux was there and Argo CD was a bit behind. Now Argo CD is actually really, really nice. They have, especially the visualization is really nice. So it's a kind of hard choice because you have to choose one tool. Now there's good news. Argo CD and Flux joined forces to create what's called the GitOps operator. I think it's called like this. Let's see. Yeah. Maybe if I add Flux as well. GitOps engine, maybe it's called. Yeah. So if you check this repo, it's actually hosted in the Argo project. The goal of this is to have a common layer so that this choice doesn't affect, doesn't impact too much your layout. So the goal is that there will be a common library that is used both by Flux and Argo CD. So they kind of merged, they're merging forces. So you can see here that they have decided to implement a reusable library that implements the core features. This means that hopefully you can even have the same repo being used by Argo CD or Flux and switch without having like a huge impact in your deployment. This was a very good outcome of the last KubeCon in November, where they announced this. We are looking forward. There's already a first version of this GitOps engine. We haven't tried it yet.
I don't see more questions.
Cool.
Ah, there is one.
Yep.
So it's from Christina from INFN. It says, hi Ricardo, and thanks for the detailed and interesting demos. Can you say something more about Helm versus Customize?
Right. So I'll be honest. Like I use Customize mostly for. Sorry. I use Customize for a single deployment. I haven't been using it for wildly, but I've been using mostly Helm. Now, the main difference, I might be wrong, but the main difference I see is that Helm focuses more on this packaging of applications in charts and then having these reusable pieces in being published to repositories, and then you can just Helm install like a remote chart. Customize is very useful if you have, for example, the full definition of your application in all the manifests of Kubernetes, and you don't want to use templating. Because templating, actually, if you look into the templates of Helm, this can get pretty silly. So I was showing before the MySQL one. Not everyone is happy to edit things like this. If I do templates deployment, so the template kind of like is messy a bit with Golang, but it's quite powerful at the same time. So what Customize does is instead of using template, it uses what it's called overlays, where basically you have your main manifests that have all the defaults encoded, and then you create overlays, which are just the parts that you want to override from the main manifests. And it's not template based. It's just it has two options to merge the values, the two manifests. So basically, for example, if you want to override just the image, instead of having like a values, you would just define an overlay that has the deployment and then defines image something else, and then Customize will merge both, and that will be the unit of deployment if you choose to use that overlay. So it's a slightly different model. I think, yeah, there's use cases for both. In our case, Helm kind of makes sense because we use a lot of external dependencies, and this makes things very easy.
There's one last question, and also we are 5 minutes over time, but I will read it out. It's from Tibor.
Yep.
A question about automated deployment of the new Docker images with Flux. How flexible is the tool?
Right. So actually, I had something in my backup slides, but I just deleted them, which is a big mistake. But let's see if I have an example. Actually, I do. In the GitOps getting started, I think I use it. The reason we don't use it is because we need to test it further, but actually it's quite powerful. So for example, Here, I'm saying that I have, this is for a Helm chart, but it's very similar for Docker as well. Here, I'm saying that the version should be, yeah, it's not a static definition. It's saying close to this version. So the semantics of what this means are different. But for example, if you would say in your values, if you would say that instead of having a specific tag, so for example, here I would say tag 118.1, but I could also say 118 and then X. I don't remember exactly the syntax, or if I just put a 118, but basically it says that it should use this as the fixed part of the tag, but then anything that would come after, it can upgrade. So for example, if you would have one by default, but I define it like this, it would pull the tag 1, and then Flux would monitor the Docker registry, and if it would see a new tag for this image that would be 118.2, it would actually do the upgrade automatically. And then what it does, because if you're hard coding the tag here, it would have to handle this as well. It needs also the ability to write to the Git repo, so you need some kind of credential in Flux, which is not the case if your repo is public. It would actually update also the release with the new tag. So I haven't played a lot with it yet, but for the next webinar, I'll try that. But it's quite flexible. You can just do kind of rejects from the versions.
I don't see any other questions.
Cool. So perfect. Then we close here for today, and yeah, we'll do a follow-up. There's quite a lot of more advanced topics to cover. I think it would be an interesting one as well. So either before the summer break or then in September. Thanks everyone for attending, and next week we have another one.
Bye.